Hey, I'm Ryan from ngrok, and this is my colleague Sam, also from ngrok. And this is the fourth installment of our series talking about how Sam is building an implementation of Kubernetes that runs in the browser. So, mate, last time we spoke, you had gone from roughly 40,000 lines of code to over 90,000 lines of code. And if I remember correctly, you just finished the kubelet, and the last stretch was working on the controllers for replica sets and deployments. I think you said you were about a week away from open sourcing it. So keen to hear what you've been up to. It's been a little while since then.
So I was actually a week away from open sourcing it, almost to the day. So we released it about a week after we recorded that. Up to, it's tricky to properly count the lines of code, but it was about like 97,000 if you remove comments and blank lines and things like that. But then if you include the demo application, the examples, it came to something like 127,000 or something like that. So, pretty substantial chunk of code. And I got the two controllers done, which when I think we last spoke, I was underestimating how difficult they would be. So they ended up being a bit of a pain, but we got through it. Interestingly, so the blog post I wrote after open sourcing it, which we'll talk more about in a minute, I calculated like token spend with LLMs, and it's really funny because in the last week it just kind of shoots up because I panicked and realized I'd bitten off a little more than I could really chew and decided to just throw tokens at the problem, which accelerated development a bit, but probably not as much as the like relative increase in token spend, as far as I could tell. And that's not like a scientific evaluation. That is entirely vibes based. But yeah, we did open source it, and I was very happy with how it was received. So at the time, I remember we crossed like 100-star threshold, and people were talking about it a little bit on Twitter, which was nice. And I was very happy with myself. And now we're kind of sat here, it's like July 8th, I think, or something, when we're recording this. And it's very, very close to crossing the 1,000-star threshold, which I wouldn't have expected when we first released it. It is the ngrok organization's most starred repo now. So I'm very proud of that.
That's a good achievement. And if we can just go back, you were saying that implementing the replica set and the deployment controllers was difficult. What made it more difficult, and like how difficult was that relative to some of the other challenges that you overcame?
Yeah, I think two things made it challenging. The first one was they were the first controllers that I was porting over from Kubernetes. The rest of the controllers I had written up to that point had to be somewhat bespoke because, for example, one of them was the kube proxy, and the kube proxy is the thing that does the kind of network configuration on the nodes, and couldn't copy that from Kubernetes because it uses IP tables and stuff like that. So made my own one of those, and then I kind of vaguely copied the namespace controller, which is actually called the lifecycle controller in Kubernetes. It's the thing that deletes everything in a namespace when you delete the namespace. But because I didn't have any notion of, I don't know what it's called. Kubernetes has this notion of I can't even think what it's called now. It's like a dynamic informer. So basically it's a way of listening to changes across every resource. So pods, nodes, services, all the custom resource definitions that you might have, they have a lot of machinery under the hood that allows you to dynamically listen to a wide range of things. I don't have that. I will need it eventually, but for the time being, I just hard-coded all of the resources I have so far implemented and listened to them individually, which is a real hacky way of doing it. So I had to make a bunch of sacrifices there. The functionality is still working, but the implementation had to be quite a bit different because I just didn't have some of the pieces that I needed. So the differences made it a little challenging. And then because they were the first controllers I had made that were really meant to be copies of the upstream ones, there were lots of bits of helper classes and things like that dotted around the Kubernetes code base that I haven't brought over yet. So while the kubelet is technically a controller, it is its own beast, and it uses all of its own stuff. So a lot of the stuff I had ported over for the kubelet didn't overlap very much with the stuff I had to port over for the controllers. So there's just this whole new set of like helper classes and things I had to come across that I didn't anticipate. I thought there'd be maybe a little more reuse between those two things, but it looks like there's a bit of a split between the way that like proper controllers are written and then how the kubelet is just its own thing. So yeah, those are the two main things.
Was there anything new that you learned about how deployments work or how replica sets work as a result of porting them over?
Broadly, no. Like they do the things I expected them to. The replica set controller is more complex than I anticipated, and I did learn about there are kind of patterns of controllers. And I ended up actually watching some KubeCon talks about this. And controllers use resources in specific ways. So, for example, on a lot of resources, when I say resource, I'm talking pod, service, node, that kind of thing. There's this status field, and the purpose of status is for the controller to report its own status, like what it's done to something, what state it's in, whether it's struggling. That is like not reserved, but like conventionally reserved for the controller, which I actually hadn't realized that. It's something that I'd seen it, and I'd seen things having a status, but I'd never made the connection that that's like a place for the controller to communicate with you, the user, and with itself later on when it comes to reconcile things again. So yeah, replica set controller, more complex than I'd anticipated, because it just controls a replica. Like it's just like you need 4 of this pod, and it has to like constantly maintain the fact there are 4 of this pod. I was like, how hard can that be? Turns out it's like pretty hard. It's like several thousand lines of code. And then once you have that down, I was like, well, the deployment controller surely is just controlling replica sets under the hood. And then turns out the deployment controller is actually its own beast. Like it, the logic for doing different types of rollouts. So the deployment controls, like when you change the image version, it will cycle pods to the new image version, but it does it in a way that's controlled. So you can say that only roll out a maximum of like 20% of the pods at a time and things like that. And that is a fairly complex set of logic that I wasn't really expecting. So yeah, it works the way I thought it would, but the amount of care in the code is very, very high and ended up being fairly complex to bring across.
And you mentioned you wrote a blog post during this time on your sort of almost similar to what we're doing here, documenting your journey. So yeah, can you tell us a little bit about that?
Yeah, so it was always the plan. So because there's such an upfront cost in making Webernetes, we knew that and this it feels bad to say these things, but you kind of do need a return on investment on this time spent. So I didn't want to make the stuff that I had to make on the Webernetes side of things and then dive into another long post-writing process. There was enough interesting stuff to say just about the process of making Webernetes that I think it warranted its own blog post, and it's a blog post that I didn't anticipate taking a long time to write because it was mostly chronicling the experience I had. So the plan was always open source Webernetes, then write a blog post about it and post that, and then I was going to go on a week time off because I hadn't taken time off in a while. And I gave myself a week to write this blog post, and it was all about, how I approached it, and it was heavily LLM generated, but in my opinion, it wasn't slop. I think a lot of people, and some people did end up accusing it of being slop, which I was expecting. I think we may have spoken about that a little bit last time, which is fine. They can believe that, but I don't personally think it is. And I kind of write about why I think that in the blog post. And that ended up being the kind of central focus of the blog post, was the process of generating almost 100,000 lines of code, but being able to feel comfortable in myself that those lines of code were genuinely quality lines of code that were doing the right thing. But I hit a bit of a snag. So it was always the plan in the blog post to have a demo of a Webernetes cluster running in that page. It has a little bit of wow factor. It fits. It's also kind of criminal to talk about the fact that you've made Kubernetes run in the browser, but not have it run in the browser in the post that you talk about that. So did that, but realized during testing it that, so I was writing it, and I tend to use Zen as a browser on the desktop. So I was using Zen, which is Firefox based, developing this thing. It was fine. Also testing a little bit in Chrome. And then I came to testing it in Safari, and on desktop, it was fine. Like, it felt a little sluggish because it's 2 sliders and then a cluster above the sliders, and the sliders control the number of replicas and they control the number of requests per second. for each, because the pods are all talking to each other. And dragging those sliders just felt a little sluggish, and I was like, that's weird. And then I open it on my phone, which using Safari on my iPhone, and it was unusable. It was so terrible. I was like sliding the slider. It took like up to 2 seconds to just change the value. So it was completely janky. And I started panicking because it was like Wednesday, and I'm like, oh no, like I've hit this performance problem. I'm out as of Friday. And I start profiling and trying to, and like the profile showed me that most of the time was spent compositing. And I was like, what? That makes no sense. Like, what do you mean you're compositing for 700 milliseconds when I change the number of replicas? I like, because it was such a simple component, and I ended up doing like it's maybe, this is maybe superstition, I guess, but I was like, okay, I'll do the contain strict trick, which is technically a layout thing. So you can tell the browser in CSS, there's a directive called contain strict. And what it does is you tell the browser, this isn't going to change size. No matter, like, nothing will change this thing. And also, like, nothing will ever go outside of the bounds of this thing. And if it does, you'll find the browser doesn't end up rendering it, because you told the browser this is strictly contained. And it's a really nice trick. I use it on quite a lot of my widgets, because quite a lot of my widgets don't change size. And it means that I can do a lot of DOM operations inside of it without triggering relayout or style recalculation for the rest of the page. But in theory, it shouldn't have a big impact on compositing, and it didn't, right? I was like, okay, I'll try this little superstitious trick I have. And the compositing was still terrible. So I just racking my brain. And then I noticed on the off chance one day, as I was just before I was going out for lunch, I noticed that if I scrolled a certain amount down the page, all the performance problems disappeared. And I was like, So I used the thing called Safari Driver, which allows you to control Safari through like an API. And I had my iPad hooked up next to me, and I was controlling it with Safari Driver. And I asked an AI agent, I was like, I know there's a certain point down this page that if I scroll down, the performance is better. Could you find that point? And it was like 742 pixels down the page or something like that. All the problems disappeared. And I was like, I'm losing my mind. What do you mean? It only happened so far up the page. But it turned out, and I briefly accused the YouTube embeds at the bottom of the post, which I was really like, I was like, oh no, I can't tell Ryan that the YouTube embeds aren't working. Because it seemed briefly as if removing those solved the problems. And I don't know quite how that measurement went wrong, but that didn't end up being the problem. Probably some like LLM hallucination, but I do remember trying it myself and it being fine. So I don't know, something weird going on there. It ended up being, a long story, at the top of the blog. You see this on the ngrok.com homepage, although it is changing in the near future because we've realized now this is just a wildly expensive thing to do for the effect that it gives. We have this SVG, which is a bunch of like glowing orbs. You'll see it on the ngrok.com homepage. You used to see it on the blog, but we removed it as a stopgap solution for the time being, so that blog post could go out and not be horrendously slow. But it's just this nice glowing orb effect. It is rendered using SVG filters. And it turns out, so I posted about this on Blue Sky as well, it turns out that it's just a known thing, like Safari is really slow at processing SVG filters, apparently. And I did confirm this on, I made like a standalone reproduction of the problem where you could turn on and off the filters, and it very clearly showed the filters of the problem. So yeah, that cost me like 2 days of slowly going crazy and trying to figure out why, when I scroll so far down the page, does this work? So that was more stressful than it needs to be. I ended up like eating into my time off slightly. Like once we had figured out that problem, it ate into what I anticipated being my kind of proofreading and editing time. So I did a little bit of that in my time off, which my wife made fun of me for. She's like, you've taken a week off and you're still working. I was like, it needs to be good. Like I can't, because the plan was to release it while I was out. I was like, I just need it to be good. I can't release something like that horrendous on the world. So yeah, it got released. And the Hacker News comments were really nice. People seemed to see the vision of it and understand it. And I got some DMs from people saying they're interested in maybe using it for something. So hopefully going to kind of connect with them and walk them through what we can do, what we can't do, what might need changing, stuff like that. So yeah, really beyond what I could have hoped in terms of reception.
Awesome. Well, we saw a good demo in the last video. Any chance that you could show us some demos today as well, and maybe even some of a behind the scenes look at the code base?
Yeah. So this is the Webernetes code base, or at least it's part of it. So I'm in the Webernetes code base, and you can see that we have like nodes and various demo things, maybe a little bit small to see. But what we're in here is, this is a terminal, so I can ls and it's all good. And this is one of the examples in the code base. So I'm going to focus a little bit on code to begin with, because I think the Webernetes demo website, which is linked in the Webernetes repo, and then the blog post I released about this has some nice visual demos, but it's probably not quite as obvious what it means. So I think you would be forgiven for believing that Webernetes is the visualization, but it's not. It's the thing underneath that drives the visualization. So, can you see my screen, Ryan? Can you read this? Brilliant. So, what we have here is what I would consider to be maybe the simplest, like non-trivial hello world for Webernetes. And it starts off with defining an image. So, Webernetes doesn't pull images from Docker Hub or anything like that. And this was something that was thought about a little bit, and we spoke about it a little bit in a previous episode, but the idea that you could potentially get real images running. So you could do some kind of like WASM compilation of the Kubernetes code base, and you can run that and pull containers and convert those to WASM. Like I think that these building blocks exist out there in the wild, and they could have been brought together. The problem with that is it would be so big over the wire. I didn't personally manage to get Kubernetes compiling to WASM myself because it does rely on a bunch of system APIs that aren't present in the browser, so the WASM compilation fails. You probably could have gotten around that. You probably could have made sufficient patches to make it compile. But even the bits that I could compile were coming to over a megabyte, and I couldn't compile very much at all. Like a Golang WASM hello world comes to just over 500 kilobytes. So like, already that's 500 kilobytes is fairly chunky over the wire. And then if it's going to end up being several megabytes, and then you have to download images as well. And most images, tens of megabytes for even small ones, sometimes up to several gigabytes if you're not careful. Didn't want that. I knew that the purpose here was to set up situations as a content creator that you have complete control over to show how parts of Kubernetes work. So we have this image API that is meant to look and feel a little bit like writing a program. So we have this exec function here, and this is what runs when you fire up a pod in the cluster. We pass in this process context, which is kind of your image's way of interacting with the rest of the Webernetes world, and we'll see more of that in a second. And then you get your argv, and your argv is the parameters that get passed in on the command line. So it is meant to feel like a process is being run here. And then the return value is just the exit code of the process. So if you exit 0, everything is fine. If you exit 1, that's a failure exit code, or anything above 0. And Webernetes kind of behind the scenes will inspect these exit codes. And if your pod needs restarting when it fails, then that will happen. If it's a job that kind of finishes successfully when things exit 0, then it knows about that as well. So in our exec function here, I think this is a little messy as it currently is, but this is because we have this base image, and our base image in Webernetes has a bunch of standard system utilities. So it will have ls, it has wget, it has like little like fake versions of system tools you'd expect to find in something like a busybox image or something like that. And the idea behind this is that this exec function is also what gets run if you exec into a pod. So I'm not sure how familiar with Kubernetes you are, but it is possible to kubectl exec and run a command in an existing running pod container. So that also happens, and it will actually call the exec on the same instance of the image as well. So it is meant to be as much like the real thing as possible. And that's relevant because these Webernetes images have container file systems. So this is a very simple implementation of a file system that's just in memory. So it's a key value store effectively. It's very, very simple. It will be extended in future when we come to do things like volumes and persistent volume claims and things like that. But for the time being, each running version of an image gets its own little file system it can do stuff with. So it has state that it can use. And when you exec into a running container, you get given that same file system. So it's a way, like through exec, you can communicate with running containers, which is used in a couple of tests and things like that. And then we have this context listen HTTP. This is a way of binding to a port on the container. This is how you would receive traffic from external sources. And then it has a callback. The callback does take a context and a request. This one doesn't need them because it just returns 200 with a body of hello from single pod. But you can inspect the request that you get if you want to, and it has a body and it has headers as you'd expect. And the last line here, wait until killed. For long running pods, I could return 0, but it would mean this listener would immediately get torn down. The pod would probably end up getting restarted and it would kind of restart loop. And obviously we don't want that. We want it to kind of wait forever. So the context has this ability to wait until it's killed. And I don't like the name. The name's a bit messy, but the idea is that because JavaScript is a single threaded runtime and it's possible to kill a cluster. So if you have a cluster, you can forcibly stop it from running. Obviously, if you want to clean up resources in a blog post or something, this is like a cooperative infinite wait. So it waits, but it does it in a way that when the cluster gets killed off, this wait will be cancelled as well, and everything will be cleaned up as necessary. So a little complex, maybe there's a lot going on in this little image, but it does define what you would imagine as a running container in a Kubernetes cluster. So I'm going to pause there real briefly. Any questions, thoughts, feelings?
Are you able to link the visualizations that you've got? Are you able to have something like a custom container here and then fire up one of your simulations so we can kind of see this image in action?
Not right now. I did not prepare quite that far ahead. What I will say in response to that is that when you go to the Webernetes demo website, this kind of thing is happening under the hood. So if I look at demo images, so we have a demo base image demo. So in the demo website, so Webernetes-demo.ngrok.app, I think we'll hopefully correct that in post if it's wrong. You will see that there are images called API. There's one called database, I think. There's one called Redis. And then this being the API image, you can see it's doing something very similar. It's listening on port 8080. It also has this ability to control the health of the pod. So in the demo app, you'll have a bunch of radio switches where you can force pods to become unhealthy. And the way that works is it is listening to requests and it is writing stuff to the file system. And then the health checks themselves read from the file system to know whether they should be healthy or not. So that's another way of using this file system to maintain some state that does something somewhat useful. Then the traffic generator is the thing that sends requests to the API pod. And we can see here, it starts as infinite loop where it just calls context.fetch. So again, this process context is just a way of interacting with the rest of the Webernetes ecosystem. And this is a way of sending requests across the cluster network. Under the hood, this fetch will know that it came from your pod and it applies all the right DNS rules. In future, I hope to implement network policy stuff. And network policies in Kubernetes dictate which pods can be spoken to from other pods and things like that. And that would plug in nicely to the way that this currently works without you having to think about it as someone authoring one of these images. But you can see here, I'm literally able to just talk to a DNS name called API. And this would also work in a real Kubernetes cluster. Like if there is a service in your namespace called API, that service is what this DNS name would resolve to. So I am talking to a service which is backed by potentially many pods. and the service DNS name will resolve to one of those pods one of those pods IP addresses. Actually, that's not true. It resolves, the services get given their own IP addresses, and then they resolve to that IP address, and then requesting that IP address does load balancing between the pods. I think I would need to go and double check this. I think I do something a little bit different in the cluster network, but the outcome is the same. I would need to go and double check that. So that could be something actually that I improve upon a little bit in future. I do think that I assign services their own unique cluster IP addresses. I'm not sure if I do the load balancing correctly. I need to think about that actually. Anyway, so yes, unfortunately, not in a great position at this exact moment to visualize what's going on here. But what I can do for you is run this example. So I'm just going to watch it. So if I do that, it says hello from a single pod, which is what we get here. So that console.log is this body here. And if I change this to say like hello Ryan and save, the watch reruns it and we get hello Ryan instead. So what is actually happening down here? First thing we do is register the image with the cluster gets its own image repository. So think like Docker Hub, but we can register our own images into it. And then we initialize the cluster and we apply a manifest to it. And this is literally a Kubernetes pod manifest. It uses the same types under the hood as the official Kubernetes JavaScript SDK. So it is the same. You'll notice, API version, kind, metadata, spec, and we set the image to example/hello 1.0, which if I go back to the top, that matches this. So whatever I set this to, actually, if I went like example Ryan, this will end up failing. It will sit and wait for the pod to be ready, but the pod will never become ready because it's trying to pull an image that doesn't exist. So it timed out waiting for a pod to be ready. So this image name here ends up being what we pull from this image tag here. This waits for the pod to be ready. There is some logic behind this that isn't tremendously relevant, but it's kind of polling the pod to see what its ready state is. Then we pull the IP address of the pod off of it, and we do a cluster fetch on that pod IP address for the port 8080 that we listened to earlier on. And then we just log out the body. So it's a nice demonstration of a pod being spun up, waiting for it to go through its life cycle so it's actually ready, then actually hitting its IP address through the cluster network and seeing that it gets the correct response back. So yeah, that is hello world Webernetes. We do have some more complex examples we can go into if you'd like, but I'm going to pause there and ask any questions, thoughts, feelings.
Yeah, I think that's really cool. One thing that was occurring to me is that the benefit of how you've got it set up here is that it's very easy to design custom images either for the visualizations that you've got, but from an education perspective, how good is it that you can quickly just whip up different images that can perform very specific tasks to illustrate a particular thing, like probes. Yes, you could do that in the real world with a real cluster by building custom images, but this just makes it so much easier. I think it's a very strong signal just how good an educational environment this can provide because, this seems very easy to be able to create custom images. But the fact that you can tailor them so specifically to whatever it is that you're trying to test or demonstrate, seems awesome.
I completely agree. And this is, excuse me, a frustration that I have had. Let's say you want to demonstrate something like probing with a real Kubernetes cluster. So first of all, you'd have to ship some kind of repo that has a way of bootstrapping the cluster, which is relatively simple with like K3s and Minikube and things like that. And then you'd have to have a set of manifests. And then if you wanted to have a custom image, you'd probably end up having to deploy either a registry within the cluster, like a custom Docker registry in the cluster, and build a Docker file and push it into the cluster, or publish the image onto Docker Hub or something like that and have people pull it down. But then if people want to make some modification and play around with it, they're either going to have to go through the process of building their own image, pushing it to their own Docker Hub account and making the modifications themselves, or have their own custom image registry in the cluster. It just seems like it's difficult to create a workflow there that allows people to poke around with things. Now, I haven't done this yet with Webernetes, but it is theoretically possible for you to allow the user, like reading your blog post, to modify the code of an image and then register that into your cluster and launch it into the cluster, right? Like there's no reason you couldn't just exec a text box with this in it and then register the image, and people are launching their own custom images into the cluster. Or you could pare it down to allow people just to edit specific things, so only give them a text box that has a function that ends up being the exec function, for example, and they could make their own change, which is like hello me, and see that running on the page, right? Like, it's because this is all client side, there shouldn't really, I don't think, be any security concerns with allowing people to exec image definition JavaScript and run it in that cluster. Like the worst thing they can do is crash the tab, and that's probably good fun for some people. It's not going to be a real problem. So I completely agree. I think it sets up a nice environment that you can, as an educator, use to show people very specific, very controlled scenarios and give them controls over that scenario. Like you saw in the demo traffic generator image, this whole idea of the health control, like allowing people to control how specific pods reply to health checks in real time through mechanisms given to you by Webernetes. So this isn't even like hacking in some variable on the side. Like you are sending a request to a pod through Webernetes that modifies their health responses. So it feels really pure that you're using Webernetes itself to modify the environment and show different things happening.
So when a lot of folks see this, they're going to maybe think that this is what Webernetes is. But what you were saying before is that this is like a visualization layer built on top of Webernetes. And I know that a lot of the people that love your posts, they love the interactivity in them. So are you able to sort of speak a little bit about how you built these visualizations, and maybe you can show us some of the code behind those as well?
The code behind these is harder to follow, but yes. Before I do that, real quick, I'll show you what I mean about the readiness thing. So if I set this API pod, which corresponds to this pod here, to not live, we should see very shortly that this will restart. So the restart counter will go up to 1 after we see that it gets, there you go. So it got health checked, it's not ready, it restarts, and now it's ready again. So we can control what is happening in the demo. And yes, this is a visualization on top of Webernetes. Webernetes is not what you see here, it's the thing driving it under the hood. So this is a React component for the cluster in the demo application. Excuse me. It is simple at the top level. I can tell you that broadly what is happening is we're using what are called informers to tell React what the current state of things are. So this use informer is reasonably complex under the hood, but the way you can think about it is that when something changes in a set of resources, so in this case nodes, so if we added or removed a node, it would trigger a React re-render with the new set of nodes in this variable here. So this informer is like in real time watching for changes, and when they happen, it will trigger a React re-render. And if we go into the node component down here, we see the same thing with pods. So we have a pod informer, and this one actually has a field selector. So what that means is it will look at the pod definition and it will match it against this expression here. So this only gets us pods for the current node. So each node is watching for changes to its own pods, and this will trigger React re-renders when that set of pods changes. So Webernetes is really quite nicely, I don't know, it works in a nice way for React in that regard. The difficulty came when, is it in here? I don't think it is in here. Demo request overlay. This is the file that's that's tricky. So this is a fair bit bigger. This is the component that controls requests moving around the screen. So I call this the request overlay. And the way that this works, I invite you to go and read the code if you want to. I can't really easily walk through it in this video. But what this does is for every request, let's see if I can see it in here. So cluster is itself an event emitter. Doesn't say that, but it will emit an event when a request is sent on the cluster network, and it will emit an event when a response is sent on the cluster network, and you can listen to those. And I think we have an example app. Network events and latencies. Yeah, so this 06, let me quickly run this for you so you can see it happening. So this logs when request and response happen. And you can see you get information about where the request came from, what the latency was, and the latency is something that you can control. So you can pass into the cluster a latency provider. And the whole purpose of this is that if this wasn't here, requests would be effectively instant and there'd be nothing to visualize. So in the demo cluster, I pass in a latency provider that adds something like 750 milliseconds of latency or something. It depends. To keep the request moving at a constant speed, I calculate the distance they have to travel, which I can do because these request and response objects tell me the source and destination of the request, which is usually the resources. So it'll be like a pod resource if it's going to a pod, or it'll be a node resource if it's coming from a node or something like that. So I can calculate the different distance it needs to travel and then make sure it's traveling at a constant speed so that it looks nice. But that's something you can pass in. That's why it's a function as well. So the function, it's not shown here, but the function can receive this event object. The event object has a whole bunch of stuff that you can introspect. But then, yeah, you can see requests going across the network and do something about it. Yeah, this overlay, it's a little complex, but broadly speaking, it listens to these requests and response, and it moves dots around the screen appropriately to make sure they start at the pod they're coming from and they end at the pod they're going to. But it's a little frustrating to me at the moment just how complex it is to do this right. I've actually had to do this twice now. So I solved this problem differently in the Webernetes demo that you see in the blog post I wrote rather than this demo app. And I think the way I did it in the blog post is nicer than the way it's done here. It works a bit better. So I probably need to come back and update this at some point. But ultimately, it would be really nice to have a library called something like ngrok /Webernetes-React that has a bunch of React components like pre-built, partly for inspiration, partly for like if you just want to put together something that you don't mind too much how it looks and you're okay with like some stock set of components that I've built for you, then you have an option for that. You don't have to build them all from scratch. So right now, Webernetes is the library driving all these things. I think it would be nice to have a set of components that we've built that kind of set the standard for what we expect, like the ways we expect you to interact with Webernetes.
Yeah, that sort of like nicely leads into my next question was, if someone goes to the Webernetes repo and they're sort of keen to explore and start using it, start playing with it, what's the best way for them to go about that?
Right now, it's not great. I'll be the first to admit. So I have not yet spent the amount of time that I should spend on documentation and things like that. The best way at the moment, I would say, is to look at the examples. So there is this examples directory with a bunch of different scenarios set up. I think that's a good start. It's a good start for getting used to how Webernetes itself works, and then download it yourself and, I don't know, use your editor to understand what options you have. Like on cluster, for example, cluster dot will show you the various things that are available to you on a cluster. Like, for example, I haven't covered this, but you can pause the cluster. And that's its whole own topic. Basically, under the hood, there is a false clock that everything in Webernetes is based off. And when you, like, all the like timeouts and intervals and queuing up microtasks and things like that can be paused in the cluster just by using this fake clock. So the cluster has this pause function, which I make use of in various places. Like when something is scrolled off the screen in a blog post, the best practice is to pause it so it's not doing anything off screen, and then when it comes back in, you resume it, so it's just not draining people's batteries in the background. That was like something I knew from the very beginning that I would need. Anyway, tangent, but yeah, go into the examples, play around with them, type stuff in, and press dot and see what methods are available to you. The probably the best thing to make this experience better in the long term is if you do this and you're confused, please tell me. And like the bits that aren't making sense to you, that's the parts that I need to focus on documentation wise. So it'd be really great to hear from you. I'm s.rose@ngrok.com. This is me here. So yeah, just send an email of what you've tried, what did work, what didn't work, and I will do my very best to get back to you as fast as I can.
Brilliant. I'm sure you'll have some people that will take advantage of that. There's been, looking at the amount of stars on GitHub and some of the comments on Hacker News, there's certainly lots of people that are interested in this. So the question that I ask it pretty much at the end of all of these chats, what's next for you? I know you've got the probes post coming up, but what are you working on next? And do you have any future plans for Webernetes? What you're going to work on? What you're going to add to it?
Yeah, the probes post is underway. I wasn't quite sure how best to frame it, and I've landed on a bit of an introduction to probing that gets like somewhat advanced, I guess. Like starts explaining like what the 3 different probe types are and what they do, and then show you kind of visually and in a way that you can play around with using Webernetes, like the different probe types, so you can go in and poke and prod stuff and see how they react. Then talking about how should you write your probes, right? Like a lot of places I've worked, the probe is quite literally just a 200 OK. It doesn't do anything. And it's like, that's probably not ideal when you understand what all the different probe types are for. So talking about some kind of common pitfalls and what you should be thinking about for these probes, and then giving people a bit of a sandbox to play with where they can put in some of their own probe configurations and see how they react in different scenarios. So that's like the broad idea I've landed on for now. And I'm not promising that's how it will end up. It could certainly change between now and when I publish it. But after that, I really like the idea of a Kubernetes 101. So like, just for someone who has never interacted with Kubernetes, the only thing they know is that Kubernetes is maybe what their company uses in production to run the code they write, but they've never interacted with it before. Can I get those people into a position where Kubernetes is far less scary? Because I think for a lot of people, it is this intractable black box of complexity, and they've heard stuff about it being a very complex beast, and they're a bit scared to approach it. Maybe they've tried reading stuff in the past and don't want to kind of rag too much on the community here, but I think a lot of Kubernetes content is hard to understand, and it's fairly advanced. It's an intimidating technology, and I'm thinking that there's a way of writing about it that is less scary, and people can actually interact with it, and it would be good, as well as the Webernetes examples, showing people like commands they could run locally in their own cluster if they wanted to. Like if this feels a bit like a toy, then these are the commands you can run to see the same outcome locally. That would be quite nice. So just to make it more real for them as well. So yeah, Kubernetes 101 would be really cool, but that's like further out in the future that I've not really thought too hard about yet.
Yeah. One thing that I would love in terms of a simulation is if you've got something on the left that could almost resemble a file system with all of the manifests that are making up everything that you see in the simulation. Because, for instance, the Kubernetes dashboard, for instance, makes it relatively easy. You can edit a manifest, you can change something, save it, and then you'll see the state updated. But if this was possible, it would be pretty amazing to have a list of manifests and you can just change one thing, and then in real time, you then get to see what happens in that simulation, because essentially you're then looking at the manifest source of truth. You can visualize what the cluster is doing. So for building the mental model where you get to see, I change this here, and then, I see the state of the cluster reflect that change. That would be an amazing visual way to see how things map from YAML to cluster state. So, mate, there's so many exciting possibilities here.
That would be doable for sure. The main roadblock to that right now is probably not what you'd expect it to be. The main roadblock to that right now is there's not that much error handling. Because I figured in the short term, I don't need to care too much about error handling because I know that I'm going to be in control of what I write. And if it's wrong, I will just fix it. So there's some error handling here and there, but broadly speaking, for a lot of properties, if you put an invalid value in there, it will probably fail silently or just in a weird way. So I need much better validation for resources, which is, very doable. I think Kubernetes itself on the API server has like a validation layer, and there's plenty of stuff I could try and copy over from there. But once that's in place, and there's just safeguards so that if we do let people go and kind of put whatever they want into that box, there is a validation that stops it from being a very confusing and horrendous experience. So that once that's in, it would be very easy to do what you're describing.
Yeah, brilliant, mate. Well, I reckon that's a good place to pause. Awesome. Thank you so much for taking us through and showing us some of the code that's behind the scenes. And I think for our next catch up, maybe we'll do it once you've got the probes post out, and we can dive into probes on Kubernetes.
Sounds good, man.
Awesome. Thanks, Sam.